This section, we talked about the circumference of a circle and arc lengths. You have a circle of radius r. So if you double it, you get the diameter. The circumference, C for circumference, is always pi times the diameter. And the diameter is 2r times pi. So we have two formulas to find the circumference of a whole circle. Now I just want to point out something. If I divide both sides by d, the d's cancel out and I just get pi. No matter what circle you have, if you take the circumference, which is the distance around, it's the perimeter, it's the distance around, and you divide it by d, you divide it by this length, you will always get pi. Whether you have a small circle and hence a small circumference. If you divide it by that distance, you'll get pi. If you take a very, very big circle, assume that's very big. If you take the distance around and you divide it by that distance, a diameter crosses the center, you will get pi. Every single time you get pi. Okay. In this section, there's really only one formula that we are going to talk about. And that's going to be the arc length formula. For example, if this is the center, so we have our central angle, and the radius is r, how big is this arc length? How big is that portion of the circumference? Well, if it turns out that this theta is 90 degrees, that's a quarter of a circle. Now we know the circumference is 2 pi r. That's the whole thing around. Well, what would this arc length, L for arc length, be? What would this be if this were 90 degrees? First of all, since I'm using 90 degrees, let's make it believable. 90 degrees. Well, what portion or what part of 2 pi r do we keep? And the answer is, well, this is a quarter of the circle. So basically, we want a quarter of the circumference. Well, 90 out of 360 is a quarter. We take the angle, we take this angle, and we divide it by 360. If I just call it theta, and I don't say anything about the angle other than it's theta, then that arc length will be theta degrees divided by 360 degrees times the circumference. 2 pi r, pi d, but we take a portion of it. If theta is 180 degrees, well, that's half the circle. That would be from here to there. That would be halfway around. And this is exactly right. The degrees cancel out. 180 over 360 is half, or C. So basically, this is our formula. Now remember one other thing. If that's theta, then we also call that theta. So the theta in the formula can be the measure of the central angle in degrees or the measure of the arc in degrees. Now we're learning how to find the measure of the arc in a length. 2 meters It's 3 centimeters, 98 miles. Show you what I mean by working out a couple of problems. Suppose that R is 20 and theta is 60 degrees. So basically, we have 20 meters. We have a circle. We have a 60-degree angle. And I'm telling you, R is 20 meters. How long is this arc length? That is, how long is this? And I don't mean 60 degrees. Because remember, if I make even a bigger circle with the same center, so they are concentric circles, well, this angle is still 60 degrees. Hence, this arc length is still 60 degrees. But clearly, this length is bigger than that length. So this 60 degrees doesn't really tell us much about the length. It just tells us about what portion we are. 60 degrees is 1/6 the way around the circle. Alright, so here is our situation, and we want to find the arc length. Well, the arc length is theta, 60 degrees, divided by the whole circle, 360, times the circumference, which is 2 times R times times pi, 2 pi R. Okay, well, the units are meters because the degrees cancel out, and 60 goes into 60 one time, 60 goes into 360, 60 times, 20 goes into both of these numbers, one from the top, one from the bottom, 2 and 3 times, and all that survived is 1 times 2 times 1, which is 2, times pi, times meters, divided by 3. So you have 2 pi over 3 meters. That is exactly how long that arc length is. What if it's a semicircle? R is still 20 meters. So if it's a semicircle, a half a circle, it's 180 degrees. Basically, that's my angle, 180, and I want to know how long this is. Well, that length is going to be the angle, the inscribed angle, the central angle, divided by 360 degrees. The degrees cancel out, times the circumference of the whole circle, which is 2 times pi times R, which is 20 meters. Well, 180 goes into both of these numbers 1 time and 2 times. 2 goes into both of these numbers 1 time. All that survived is 1 times 20, which is 20, times pi times meters, divided by 1. The rule for dividing by 1 is don't bother. It's 20 pi meters. That is how long this is. What exactly does that mean? That means if I take a string and I attach one end here and I move it, I lay it out along this arc, and I stop there. If I literally take that string that only goes from here to there, and I bring it to a ruler that's in meters, and I lie one end here, and I stretch it out to the end, it will be 20 pi meters right there. That's exactly how long it is. You made it straight. Length is one-dimensional. You can't talk about a length really like that. You can say that that becomes this, because this isn't two-dimensional. Okay, but since, okay. How about there's a track that goes like this. It has 4 straight pieces, parallel, equal in length, but the corners are circular. The corners are circular. Okay, so curved part, curved, curved, curved. Straight, 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 and straight. And the question is, say, what's the perimeter? Suppose I tell you this is 10 meters, and I tell you that this piece is 15 meters. Same thing, 10 meters, 15 meters. And then I tell you that this is 3. 3, 3. I tell you that that distance is 3 and that distance is 3. Same for the top left. Okay, so the perimeter is all the way around. But just remember, the sum of the parts is the whole. We have 15 plus, we have another 15 plus, we have 10 and 10. You want to call it 20, call it 20. All right, 10 and 10. And then you have 4 times this, because there's 4 of them. Well, this is a quarter of a circle. This is a quarter of a circle. You have this piece in one corner, this piece in another corner, this in the top left corner, and this in the bottom left corner. Well, I'm telling you that this distance is 3. And this distance is 3. That is, that's 3 and that's 3. We have the diameter. The circumference is d times pi. 6 pi. So, I already found out what the 4 times is. Each one of those is 1.5 pi. But the whole thing is 6 pi. You have 30, and 10 is 40, and 10 is 50. You have 50 plus 6 pi. Please don't say you have 56 pi. Because if pi was 2 million, if you have 2 times a million, and you just add it to $50, you shouldn't have much more than 2 million. You should have 2 million. Well, instead of 2 million, I don't know what I was thinking, let's say 6 million. If you have $6 million that you're about to deposit into a bank account which has just $50, compared to the million, it's next to nothing. Okay? You should have a little bit over 6 million. you should not have 56 million. Because if you have a bank that will agree with that, what you do is you find somebody who will loan you for just a few minutes 6 million. Put $50 into the bank, put in 6 million. You now have 56 million. Pay the person back his or her 6 million, and now you have 50 million. Shucks, give them back 7 million for the trouble. Now you'll have $49 million. And all you did was put in $50 of your own money, and you gave somebody $1 million. And now you have $40 million. Well, of course, that makes no sense. So the answer is 50 plus 6 million. Let's do a couple more of these problems. That's how you learn, by doing problems. Okay. Suppose you have a window. It's called a Norman window. You have a rectangle. This is not part of it, but there's your four-sided rectangle. And you have a semicircle on top. That is your window. And I'll even make it easier. I'll say that those three sides are the same, and they're all 10 centimeters long. Question is, what's the perimeter? Well, the perimeter is everything in black except those dashes. Okay, well, let's go around. 10 centimeters, 10 centimeters, 10 centimeters. Well, that is 30 centimeters. But there's more. There is this half a circle. Well, I'll divide it by 2. Let's imagine it's a whole circle. Well, let's even put it in the picture. Whole circle. Well, if this is 10 centimeters, well then so is that. But that's the diameter. The circumference is pi times d. It turns out centimeters. It turns out that 2 goes into 10 5 times. So it's not 20, excuse me. It's 30 centimeters plus 5 pi centimeters. Okay? You probably might want to call this 30 plus 5 pi centimeters. Just like x's and y's and 7s and 15s and 11s and -4s, you can factor out units. 30 plus 5 pi centimeters. This is a little bit more than 15. 3.14 times 5 is 15.70 plus 30. It's about 45.7 centimeters. But nonetheless, that is the exact answer. And personally, I like the exact answers. Who wants an approximation? It's a math class. Exact answers. Let's try another one. Suppose you have this problem. You have a corner, right angle, and you put something round in it. A circle, a garbage can. You put something round in it. Put something round. And suppose you're told the diameter of the can is 48 inches. And you want to know two things. Let's call this O. let's call this point A and B. You want to find OA, which is the radius, and you also want to find OB. So let's write OB. You also want to find AB. If you find one of those, you know the other. OB and AB. Okay, so the diameter is 48. This distance is 48, which tells me that that distance is only 24. This distance is 24 inches, and that distance is 24 inches. So let's draw what we have. We have a circle, and they're tangent. They're tangent. This point and this point is tangent to the circle. And you have all this symmetry. So when we go to the point B, we go like that. Well, I was about to say it bisected that angle, but that's neither here nor there. Now, we know this is 24, and we know this is 24 inches, and it's a corner, so it's a right angle. And since this line is tangent to the circle, when I go from the center to that point, that's another right angle. Same thing over here. That's a right angle. You have a four-sided polygon with three right angles. Think again. You have four right angles. And the reason is, if you have four-sided polygon, take away 2 from the sides, multiply it by 180. You have 360 degrees all the way around. Again, the reason is, if you cut it in half, this angle plus this angle plus that angle is 180. This angle plus this angle plus that angle is 180. But the four angles of the polygon, it's 360. And the the 390-degree angles that we know about leave 90 left over. 3 90s or 2 70s. So this last one is also 90 degrees. Okay. 24. So let's look at, I'll scale it up a bit, but let's look at the top left-hand triangle. Let's give these some names. OCB. OCB. This is 24, and this is 24. Well, if you call them 1 for a moment, 1, 1, Pythagoras can help you figure out this other side. 1 squared plus 1 squared is 2. So this side is square root of 2. Because when you square this, you get 2, and that equals 1 squared plus 1 squared. Okay. But they're not 1s, they're 24s. This one got multiplied by 24. This one gets multiplied by 24. So does that hypotenuse. It gets multiplied by 24. It is 24 the square root of 2, which is good. Now I know what OB is. It's 24 square root of 2. Now, OA is a bit, remember, A is right here. Let's go to the original picture. OA is a radius, and all radii are 24. Okay. Now, AB is part of OB. It's OB, but then you take away OA. Right here, I have OB. And I know how long it is. It's 24 square root of 2. And if I literally take away OA, which is 24, I'm left with AB. I am left with AB, which is what I want. Okay, so OB is 24 square root of 2 minus OA. These numbers are here. Minus 24. You factor out the 24, and you get what AB is. It's 24 times the square root of 2 minus 1. Very nice problem. Algebra students or geometry students should definitely know how to do that problem. And that finishes the section and even the chapter on circles.